Now that we know about the properties of our waves, let's look at how our waves behave. One way is that waves can be reflected, which means that they're going to bounce off of a surface that they cannot travel through. That's not going to change the speed of our wave, but it can flip it upside down. So if I look over here, I have my red wave coming at this reflective surface, maybe a mirror, and as it reflects it, it can change it and make it go upside down. But notice that the wavelength of that wave would be the same, the frequency would be the same, everything's the same except that it's upside down. Speaking of the speed of the wave, let's talk about how we can calculate that. We would either take the wavelength and divide it by the period, or how much time it takes for one cycle, or I can take the wavelength and multiply it by the frequency. In either case, if I'm using meters for the wavelength, then the speed is going to be in meters per second. The second behavior I have is refraction. This is when my wave is going to bend, so I am going to change the speed, I am going to change the frequency, etc. And the reason that it bends is because it's entering a new medium. So it's entering a different kind of matter, and when it does so, it has to do it at an angle. What happens is part of the wave is going to slow down, while the other part continues moving at that original speed. So in this case, if I have a wave traveling through the air at an angle and it hits the water, so a new medium, it's going to travel through the water at a different angle. So my wave has bent. Number 3, diffraction, is still going to be bending of a wave, but the reason it happens in this case is because the wave is either going around an obstacle or it's going through a narrow opening, which I've shown here. So I have my wave, it goes through this narrow opening, and as it goes through, it bends like that. So I can bend my wave in two ways, either refraction or diffraction. They happen for different reasons. Interference is when I start to combine my waves. So if I have two or more waves that start to interact and overlap and combine, that's called interference in general. We have two specific types then. If I have two waves that combine and they make a larger wave, so it has a larger amplitude, we call that constructive interference. If I have two waves that combine and they make a smaller wave, or it has less amplitude, that's destructive interference. Now the example I've drawn here, we end up with a straight line, but that is not always the case. If we do end up with a straight line, then this is called complete destructive interference. And number 5, a standing wave. This is a wave that appears to stay in one place. So in this case, what I have is usually a string or a chord, so think of like a guitar string that's anchored on its two sides. If I apply energy to that and start sending a wave down, so my black wave comes down, it hits this end, and then the blue wave ends up coming off of that. This is going back and forth so quickly that I appear to have these open areas where a crest and a trough are happening at the same time. And then I have these closed areas where there is no displacement at that point. Those points where they're closed are called the nodes of the standing wave. The parts where they are open are called the antinodes. Something to mention about standing waves is if a standing wave comes into contact with another wave that has the same frequency, then we say that that standing wave is going to resonate. So we call that resonance. And when that happens, it ends up amplifying the sound. So it ends up making it louder. We haven't talked about sound yet, but when we do, this will make a little more sense. So it'll amplify the sound, which for some instruments, we want that to happen, like in a piano. Even though there are strings vibrating in the piano, and that does make a certain amount of sound, it doesn't make enough sound that we could hear it and enjoy it. So what we use is a board, really a wooden board, called a soundboard. And what that does is it sets up this resonance to amplify the sound that the piano is creating.